Hi, my name is Hitarth Mehta and I will be presenting my final project of EEE 6512 class. My final project is image classification using k-nearest neighbor and support vector machines. For this project, I have used a Caltech 101 image dataset. This image dataset has approximately 101 categories, and each category has around 50 to 800 images. For simplicity, I have used 40 images of 10 different classes. In the next few slides, I will be explaining the importance of image classification, the difficulties in image classification, and the solution for it. Uh, then the next slide represents the steps required for image classification. Then I will go through different algorithms that I have used for this project. For feature extraction, I have used scale invariant feature transform with bag of word model to represent the images in the training dataset. Then for clustering, I have used k-means algorithm, and then I will be explaining about two different classifiers, that is k-nearest neighbor and support vector machines, and then I will go through the results and demo and then the conclusions. So what is image classification? Image classification is one of the fascinating research area in the recent years. Though this task seems simpler for humans, it is not as simple as for machines, and because the reason is that the data set is getting more and more bigger. So for machines to classify images correctly, it has to pass through several pre-processing steps. The usages of image classification. This technique is used in internet search, social media, then advanced driver assistance system (ADAS), that is emerging field right now, computer vision and real-time robotics. In this slide, I have presented the image classification stages. The first and foremost step is to separate the classes depending on the motivation of the problem. So in this project, I have used Caltech 101 dataset, and each and every images in the dataset is classified according to the class. The next step is a feature extraction class. The goal of this feature extraction is to find the key points of the images, such edges, corners, blobs, etc. The next step is the selection of training data. This is one of the crucial step in image classification because the accuracy depends on the number of training data as well as testing data. Sometimes you may want to use principal component analysis or PCA to reduce the dimensionality. If we are given an image with high dimensional subspace, then we may use a PCA. But for this project, I have not used PCA as a pre-processing step. The next step is the classification, and the final step is accuracy measurement. In the final step, the accuracy is measured by finding the ratio of number of images that are correctly classified divided by the total number of images given to the classifier. Scale invariant feature transform. The reason why I have selected SIFT feature extraction among all other options is that the SIFT is local descriptor and it is invariant to scale, illumination, etc. The meaning of invariance to scale is that the descriptor should be capable of finding the correspondence between two transformed images if we scale the image. And SIFT is unique and discriminative. So after finding the key points, SIFT algorithm represent each key points as 128 dimensional vector. But the problem with SIFT is that SIFT cannot uh, represent all the images in the dataset. So bag of word model is used with SIFT algorithm to represent entire image dataset. Bag of word model is taken from the text analysis, and it creates a vector of occurrence counts of the word in the database. So similarly, in computer vision, instead of using these words, we are using discriminative features, and the vocabulary of these discriminating features or visual words is created using clustering. So in the given figure, you can see that there are three different images of a different kind of shoes, and the shift algorithm is performed on these images, and the extracted features are stored in a bag. Then this bag is given to the clustering algorithm, and after the clustering, it will give you a code book, and it contains the number of code words. So after, when a query image is given to this model, this image will be represented as the histogram, and the beans of this histogram will be the code words obtained from the previous step. K-means clustering algorithm. K-means clustering algorithm is unsupervised learning technique, because we don't know the classes beforehand. Let's say we are given n observations of m dimensional space, and we are given k clusters. Then the aim of K-means clustering algorithm is to find Euclidean distance such that it is minimized for every observation points. The goal of K-means algorithm is to minimize the intercluster distance and maximize the between cluster distance. So you can see that this in the image. The next is the k nearest nearest neighbor classifier. K nearest neighbor classifier is one of the simplest supervised learning algorithm. It is supervised because we know the classes of the images beforehand. KNN is instance-based learning because the model is not learned beforehand, and when the query image is given to the dataset, this image is compared with each and every images of the training dataset to find the closest neighbor. In the given image, you can see that if you want to find the closest neighbor for the green circle, then if k is 1, then the closest neighbor would be rectangle. If k is equal to 5, then the closest neighbors will be red diamonds, and if k is given 7, then the closest neighbor for the green circle will be purple triangles in the C region. The next is support vector machines. Support vector machines is also supervised learning model. SVM is non-parametric because there is no prior assumption about the data. In few classifiers, it is assumed that the input data has Gaussian distribution, but in this case, it is there is no prior assumption. SVM tries to divide classes such that the distance between this category is maximized using hyperplanes. In this project, I have tried different kernels like linear, polynomial, radial basis function, and sigmoid, and I have achieved a best accuracy of 64% using radial basis function. Next, I will show you the demo. I will show you the KNN classification. So here you can see that I have used learn.py file, and I have given the path for the training dataset. So when I press it, you can see that all the images from the training dataset is read, and then after this reading, the shift algorithm will be applied to these all the images. So here you can see that in the training data set there are 10 categories, and each category has 40 images. Yes, so you can see that we have read 100 images. So for simplicity, I have read 100 images, but in this project I have read over 400 to 1000 images. So after learning process, I will classify the images of the testing data set. So here you can see that in the testing data set, I have again 10 categories, and each category has 10 images. So for testing, I will run the classify.py file, and I will give the path of the testing data set. you can see that the different labels for different categories. So after running this file, a confusion matrix will be created. So confusion matrix is the x-axis represent the predicted label and the y-axis represent the true labels. So here you can see that the dollar bill and faces is the most accurately classified categories. In confusion matrix, the diagonal entries represent how accurately each class is classified, and the off diagonal entries represent how each class is misclassified. So here you can see that for dollar bill it is 10 and 10, and dollar bill and faces it is 10. So dollar bill and faces are most accurately classified uh, categories. But and here you can see that the cup is the least classified class. After that, I'm showing an image with its label. So you can see that the image is classified as faces. So yes, this is correctly, this image is correctly classified. So SVM with radial function outperforms the k nearest neighbor, and the accuracy is 64% and 48% respectively. For training images 40 for each class, and testing images 10 for each class. The dollar category is the most accurately classified category among the two classifiers. For k nearest neighbor, as the value of k is increased, misclassification is decreased, and the best obtained value for k is 13. One of the advantage of k nearest neighbor over SVM is that it takes less time to learn the model. I would like to thank Dr. Depeng Vu for his constructive teaching of Triple E 6512 class. I would also like to thank Mr. David Ojika for giving his constant inputs and support. Thank you.